Morning, all of you. Today I will explain Sumpners test on transformers. Sumpners test. Sumpners test is also called back-to-back test. Sumpners test is also called back-to-back test. This test is used to determine the efficiency of the transformer and to determine the regulation of the transformer. The third one is to determine the temperature rise of oil of the transformer. So we can able to determine efficiency, regulation, and temperature rise. Oil temperature rise of the transformer is measured with the help of Sumpners test. This test is also called back-to-back test or temperature rise test. So key points in this test is, in this test we use two identical transformers. Suppose if you want to determine the efficiency of one transformer by conducting Sumpners test, so you need two identical transformers. So similar transformer is required. One more similar transformer is required. So that means two identical transformers are required in Sumpners test. Two identical transformer means as far as concept power rating, voltage rating, and frequency, all ratings are equal. So that means that is the two identical transformers are required in Sumpners test. Actually, in open circuit test and short circuit test, also we determine the efficiency and the regulation of the transformer and efficiency of the transformer determined with the help of OC and SC test. And equivalent circuit parameters is also determined from the OC and SC test. But in OC and SC tests, in OC test, two tests, OC and SC tests, two tests are conducted one after another one. The first open circuit test is conducted, and then short circuit test is conducted on same transformer. But actually, in open circuit test, we get core losses. In short circuit test, we get copper losses. So one after another one means temperature rise. That means total losses not occur at the same time, and that is not also continuous test. Continuous means 1 hour or 2 hours. Just to take readings and complete the test. But temperature rise of the transformer does not occur because two losses does not occur simultaneously. Two losses occurs one after another one. Core losses first, then copper loss. So that means that does not give temperature rise and accurate results of the losses also. So to overcome that one, we conduct another test, that is Sumpners test. In this test, we need two identical transformers. Next one is, in this test, in Sumpners test, two transformers primaries are connected in parallel, and two transformers secondaries are connected in series position. Primaries are connected in parallel. Secondaries are connected in series opposition. We apply rated voltage on primary side with the help of a auto transformer. We apply rated current on secondary side with the help of a auto transformer. In this test, wattmeters are connected on primary side and secondary side. The primary side wattmeter measures core losses in two transformers. So if you want to calculate core losses in one transformer, the wattmeter reading by 2, because that wattmeter measures core losses in two transformers. Some of the core losses in two transformers. Next, secondary side wattmeter measures copper losses in two transformers. So you want to calculate the copper losses in one transformer. The wattmeter reading by 2 gives the copper losses in one transformer. Then from that we calculate the efficiency, regulation, and temperature rise. This temperature rise means this test is continuously conducted 1 hour, 2 or 3 hours. Therefore, temperature rise occurs in the transformer. Therefore, we measure the temperature rise of the transformer I with the help of Sumpners test. So introduction, the Sumpners test. Sumpners test is also called back-to-back test. The Sumpners test is also called back-to-back test. Why we call it back-to-back test means two transforms are connected in series of position. The second is, it is a very practical, convenient and efficient and a minimum power consumption test. Minimum power consumption test which is done without actual load. Actually in this transformer we cannot load the transformer actual load. We create imaginary load. To find the regulation efficiency of large power transformers. To find the efficiency regulation of the large power transformers. So another power is temperature rise is also calculated from this Sumpners test. It is an improved method of testing of transformer efficiency and other parameters. This test gives the value of the total losses accurately. Total losses means core losses plus copper losses accurately as it occurs when it is actual use. The Sumpners test or back-to-back test, or it is also called temperature rise test. It requires two transformers of identical rating. This is also very important. Requires two transformers of same rating. Important point. In this test, we need two transformers. Both transformers are connected to supply in such a way that one transformer is loaded another. So one transformer acts as a load for second transformer in this method. Actually, we have conducted two tests in transformers. Open circuit test, OC test. This is the OC test. Open circuit test and short circuit test. So from open circuit test, we get core losses. In short circuit test, we get the copper losses. Short circuit test, we get the copper loss. But these two tests are conducted one after the other, not simultaneously conducted. When first OC test is conducted, from OC test we get the core losses and shunt branch parameters of the equivalent circuit. From short circuit test, we get the copper losses and series branch parameters of the equivalent circuit. Okay. Open circuit test, second is open circuit test is conducted on the LV side. In short circuit test, second is shorted and test is conducted on the HV side of the transformer. So already we have two tests. Why we need this Sumpners to determine the same things? Same things means copper loss, core losses, copper loss, and equivalent circuit parameters, efficiency and regulation. Same things is obtained from Sumpners. Why we need another test? So because two tests we get losses simultaneously, not instantaneously. So drawbacks of the open circuit test or short circuit test. Open circuit test, there is no load on transformer, while in short circuit test only fractional load gets applied. In all open circuit test and short circuit test, the loading conditions are absent. So if the loading conditions are absent, hence the results are inaccurate. In open circuit test and short circuit test, iron loss and copper loss are determined separately. In actual use, both losses occur simultaneously. So one after another one means losses occurs one after another. So but actually loading condition, two losses occurs at same time. Temperature rise of the transformer is due to total loss that occurs simultaneously during actual use. It can be determined by, cannot be determined by OC and SC test. Cannot be determined by OC and SC test. Okay. Very important point. The Sumpners test requires two identical transformers. Both transformers are connected to supply, so that one transformer is loaded another. So that means one transformer acts as a load for second transformer. in Sumpners test. Power taken from the supply is that much necessary for supplying losses of both transformers only. That means two transformers takes power from the source only to meet the losses in the transformers. Losses in the two transformers. Losses in the two transformers. While conducting this test, primaries of the two identical transformers. So primaries of the two transformers are contained by very important. While conducting this test, the primaries of the two identical transformers are contained parallel. Next, secondaries are connected in series opposition. This is also the first point. Primaries are connected in parallel. Secondaries are connected in series opposition, so that the induced EMF and the secondaries oppose each other. The secondaries are supplied from another low voltage supply are connected to the circuit to get the readings. Okay, that will explain the circuit diagram. First of all, I will explain once again explain the open circuit test and short circuit test. See, suppose this is a transformer in the open circuit test. So LV side is conducted on LV side. So here this is the transformer. Minimum number of turns means that is the LV winding. Lower number of turns. More number of turns means that is the HV winding. More number of turns means the HV winding. So here we conduct test on LV side open circuit test. So to measure the voltage, we can connect a voltmeter across the terminals. So this is the OC test. OC test. So we have an auto transformer. Auto transformer having single winding. That means we have variable supply. So we have an ammeter to measure the current. So in any test, OC test or SC test, we have 3 meters: ammeter, voltmeter, and wattmeter. This is the wattmeter. This is the wattmeter. Now we have voltmeter, ammeter, and voltmeter, and wattmeter. 3 readings in open circuit test. Ammeter gives current rating. Voltmeter gives voltage rating. Wattmeter gives power rating. So wattmeter measures the core losses in the transformer because we apply rated voltage. Current is very small. Current is very small means copper losses is very small. So therefore copper losses is neglected in the open circuit test of the transformer. So copper losses, why copper losses is small in open circuit means current is very small, no load. So no load, no load. This is a no load. Second is open circuited. Second is open circuited. Second is open circuited means no current in secondary side. So that means I2 equal to 0. I2 equal to 0 means no current on secondary side. So primary takes small amount of current to meet the losses, small losses, to produce the working parts in the transformers. So that's why primary current is very small in open circuit test. So therefore copper losses is small. Therefore wattmeter measures only core losses in the transformer in open circuit test. In open circuit test, wattmeter measures only core losses in the transformer. Next, short circuit test. Short circuit test. Similarly, here also we have a transformer with more number of turns on primary and less number of turns on secondary. So secondary is shorted here. So this is short circuit. Short circuit. So we have 1 ammeter, 1 wattmeter, 1 voltmeter, and we have another auto transformer to give variable supply voltage. So this is the circuit diagram. HV winding, because test is conducted on HV side. LV side is shorted. And this is the wattmeter. So in this test, we apply very small voltage. In this test, you remember, in this test we apply very small voltage. In open circuit test, we apply rated voltage. In open circuit test, we apply rated voltage. In short circuit test, we apply very small voltage. That small voltage is enough to circulate the rated current on primary side. Because secondary is shorted. Secondary shorted means small voltage is enough to circulate the rated current in both sides, primary side and secondary side. So that way, so we apply small voltage to circulate the rated current in the primary side. So the primary carries rated current, secondary is also carries a rated current. So that is, in open circuit test, we apply rated voltage. In short circuit test, we apply rated current. Rated voltage, rated current. In open circuit test, primary is secondary is open circuited, in short circuit test, secondary is shorted. Okay, next. So in this test, in short circuit test, we apply small voltage. So core losses is very small. Why? Because core loss depends upon voltage and frequency. If we apply small voltage, so therefore core loss is small. Therefore core loss is small means what is neglected. So that means in short circuit test, wattmeter measures copper losses only. In open circuit test, wattmeter measures core losses only. Okay, ammeter measures the current. Voltmeter measures the small value of voltage from this voltmeter. Okay, so that means in two tests, open circuit test and short circuit test, open circuit test. So this test, open circuit test is conducted on LV side. This test is conducted on HV side. So suppose apparatus. So second is open circuited. Second is open circuit. Second is short circuited. We apply rated voltage. We apply rated voltage. We apply rated current. Rated current. Rated voltage, rated current. Open circuit to short circuit. Here wattmeter measures core losses. Core loss. Here wattmeter measures copper losses. Core loss and copper loss. Wattmeter measures core losses, and here wattmeter measures copper loss. Open circuit test, short circuit test. Conducted LV side, conduct HV side. Second is open circuit test, second is shorted. Here we apply rated voltage, here we apply rated current. Here wattmeter measures core losses, here wattmeter measures copper losses. But in the Sumpners test, these two tests are conducted simultaneously at the same time. In Sumpners test, open circuit test and short circuit test, both tests are conducted simultaneously. That means at the same time you conduct open circuit test and at the same time you conduct a short circuit test. Okay, so that means primary side is conduct, open circuit test is conducted on primary side, short circuit test is conducted on the secondary side in Sumpners test. I will explain how the test is conducted in Sumpners. So in this test we need two transformers, two identical transformers. So these are the two identical transformers. On these two transformers we conduct a test. See, so these two transformers primaries are connected in parallel. In this side, primary side, parallel. So primary side is connected. Secondary side are connected in series. primaries are connected in parallel, secondaries are connected in series opposition. Series opposition means two windings are connected in series opposition. We conduct a test on these two transformers because in Sumpners test we need two identical transformers. These are the two identical transformers. Two identical transformers. These are two identical transformers. Two identical transformers. We need two identical transformers. Those primaries are connected in parallel. Secondaries are connected in series opposition. Secondaries are connected in series. So we apply rated voltage on primary side with the help of a supply. With the help of this supply, we apply rated voltage on primary side. So explain how. Suppose these two are the transformers. These two are the identical transformers. So we conduct some bus test on these two transformers. So primaries are connected in parallel. Suppose this is the bus bar line. So primaries are connected in parallel means suppose this terminal is connected to this line. So second transformer is also connected in the same manner. So see here connection. Okay. అలాగే ఈ లైన్కి దీన్ని కనెక్ట్ చేస్తాం, దీనికి దీన్ని కనెక్ట్ చేస్తాం. అట్లా ఫేజు న్యూట్రల్, ఫేజు న్యూట్రల్. Suppose this one is the phase, this one is the neutral. So in the if you connect the transformer primaries in this manner, the two transformers are connected in parallel. So secondaries, secondaries are connected in a series opposition. Series opposition means suppose ఇది ప్లస్ ఇది మైనస్ ఉంది, ఓకే, ప్లస్ మైనస్. మన ఇక్కడ ఫర్ ఎగ్జాంపుల్ ఇది ఒక 100 volts ఉంది అనుకోండి, సెకండరీ వోల్టేజ్ 100 volts, మళ్ళీ ఇది ప్లస్ ఇది మైనస్ ఉంది, ఇక్కడ 100 volts. సో నెట్ ఈ రెండు కలిపితే మనకు నెట్ వోల్టేజ్ రాకుండా సిరీస్ అపోజిషన్ అంటే సపోజ్ ఇట్ నుంచి స్టార్ట్ అవుతుంది కదా, మైనస్ ప్లస్ మైనస్ ప్లస్ అట్లా ఉంటే రెండు యాడ్ అవుతుంది. ఈ రెండు ఇలా కలిపాము మైనస్ ప్లస్ మైనస్ ప్లస్, టోటల్ వోల్టేజ్ ఎంత అవుతుందండి ఇక్కడ? టోటల్ వోల్టేజ్ 200 volts. 200 volts. That means this transformer having 100 volts, this transformer having 100 volts. Total voltage equal to 100 volts. Similar like batteries, two batteries are connected in series with each other. ఇలా కాకుండా opposite. మైనస్ ప్లస్ ఇట్లా వేసాము, మైనస్ ప్లస్ అప్లై చేస్తే ఇక్కడ ఈ నెట్ వోల్టేజ్ ఈక్వల్ టు 0, వోల్టేజ్ ఈక్వల్ టు 0. The net voltage equal to 0 volts, 0 volts. So it is series opposition. Two transformers are connected in series and opposition. Two transformers are connected in series and opposition. In this manner, we connect the secondaries. Okay. Two transformers are connected in series, so two windings are connected in series. Two windings are connected in series. Two windings are connected in series. కరెంట్ ఇలా వచ్చి ఇలా వెళ్ళి ఇలా వచ్చి ఇలా వచ్చి సిరీస్. సో దట్ మీన్స్ టూ వైండింగ్స్ ఆర్ కనెక్టెడ్ ఇన్ సిరీస్ అండ్ ప్లస్ మైనస్ మైనస్ ప్లస్ మీన్స్ అపోజిషన్, సిరీస్ అపోజిషన్. సో ఇన్ దట్ మేనర్ వి కనెక్ట్. దీంట్లో రివర్స్ సైడ్ అంతే, మనం అట్లాగే కనెక్ట్ చేయొచ్చు. ఓకే, సో టూ ట్రాన్స్ఫార్మర్స్ సెకండరీస్ ఆర్ కనెక్టెడ్ ఇన్ సిరీస్ అపోజిషన్. సో వీ గివ్ supply. With the help of some other transformer, will be supplied with the help of other transformers. ఇదంతా యాక్చువల్లీ సప్లై ఇవ్వడానికి పెట్టుకునే సప్లై సిస్టమ్ ఉంటుంది. The help of this transformer will be supply. So we apply rated voltage, we apply rated current on this side. We apply rated voltage here. On primary side we apply rated voltage. On secondary side we apply rated current. Rated voltage, rated current on this side. So the base of this wattmeter measures core losses in the transformer. This wattmeter measures copper loss in the two transformers. Copper loss in the two transformer. This wattmeter measures core loss in the two transformer at same time. At the same time. So this test is conducted continuously with 3 hours, 4 hours, 8 hours, depending on the size and operation requirement to measure the temperature rise of the transformer. So from this test we calculate the efficiency of the transformer, regulation of the transformer, circuit parameters of the transformers, and temperature rise of the transformers also. Okay. The secondaries are connected so that their polarities are in opposition. See, polarities are opposite to each other. They will be this one. AB equal B, AB equal BCD, A joins C, and B just join to D. There would be no secondary current, flowing around the loop or by the secondaries. With the help of the secondary source, switch flow chasing with the help of secondary transformer, we circulate the current in this loop. This short circuit test procedure we follow. Here open circuit test procedure we follow. Hence W1 continuously read the core losses equal to the full load copper loss in two transformers. So obviously power taking is twice losses of the single transformer. This is the Sumpners test without supplying load, full iron loss circuits into full load copper loss circuits in the winding simultaneously. Hence, heat run test can be conducted on two transformers. Hence, heat run must be conducted on two transformers. Advantages. What required to carry out test is one. Transformers are tested at full load condition. Other test results gives the value of core and copper losses occurring simultaneously. So heat run test can be conducted to transformers. See, secondary current can be varied using regulating the transformer. Hence, we can determine the copper losses at full load condition at any load. If you have any doubts? So once again I repeat, Sumpners test is also called back-to-back test, also called heat run test. This test is conducted to determine the efficiency, regulation, and temperature rise of the transformer. In this test, we need two identical transformers. So in this test, we connect to primaries in parallel. Secondaries are connected in series opposition. We apply rated voltage on primary side. We apply rated current on secondary side with the help of auxiliary sources. Then we take all the meter readings. From that, we calculate the efficiency on the regulations. Okay. We identify transformers. Primaries are connected in parallel. Secondaries are connected in series opposition. We apply rated voltage on primary side. We apply rated current on secondary side with the help of the voltage sources. In this test, two wattmeter measures primary wattmeter measures core losses in two transformers. Secondary wattmeter measures copper losses in two transformers. If you want to calculate the efficiency of one transformer, the copper losses and core losses is divided by 2 because wattmeter measures core losses and copper losses in two transformers. Okay. So in this method, in this manner, we calculate the efficiency of the transformers by conducting the Sumpners test. Temperature rise is measured by directly measuring with the help of a thermometer or other temperature measuring equipments. Okay, so that means open circuit, if you compare this test with open circuit test and short circuit test, in this test, primary side we conduct open circuit test, secondary side we conduct short circuit test, but two are conducted at same time. That's all. Do you have any doubts?
Or back-to-back test of transformers. So we need to know why we are conducting this test on a transformer. The main reason is used to find regulation, efficiency, and heating conditions. Heat under no load conditions. So this is our requirement from this test, that we are going to find regulation, efficiency, heating under no load condition. This regulation and efficiency we can find from OC and SC test also, but we can't find the heating conditions. So this is the main purpose of this test, that is Sumpners test. In the Sumpner test we are going to conduct OC test and SC test at the same time, but we can't identify where the actual operation of OC test and SC test is operating here. So let us discuss about the circuit diagram first. So here you can see there are two supply lines. These are called supply lines or supply bus bars, and a voltmeter is connected across the supply lines and a wattmeter as well. And these tests can be performed only when two identical transformers are available. Here T1 and T2 are identical transformers. So this test can be performed only when identical transformers are available. So the primaries of the two transformers are connected parallel to the supply lines, and the secondaries are connected in such a way that in series, but in such a way that whatever the EMF induced in the transformer will in the primary of secondary of T1 transformer will oppose the induced EMF in the secondary of T2 transformer. So here the EMF, if it is E2, here if it is E1, the resultant of this will be E1 minus E2 will be equal to 0. So this is the condition going to happen. So whatever the EMF induced in secondary will be going to nullify each other. So if there is no voltage, there will be no current flowing through the secondaries. So if there is no current, no drop, or means if there is no current, ultimately we don't have any power drawing from the secondaries. So here the wattmeter will directly indicate the core losses of the two transformers. So it can be let us write these steps. Identical can be performed only for identical transformers. Connections, I will give this about connections configuration in PDF. Let us complete the video first. And the wattmeter one will read core losses in transformer, I mean in both the transformers, that is T1 and T2. If we want the core losses of one transformer, that is Pi is equals to W1 by 2. W1 is nothing but the whatever this wattmeter is reading. So this is one case. So here if you observe, there is another transformer connected. This transformer is connected to supply a small voltage, is used to supply small voltage to the secondaries of the this T1 and T2, means identical transformer, because at first there is no EMF. There is EMF, but they are in opposition. So in order to provide some additional EMF, we are using this transformer, that is this transformer denoted by T. So it will supply some small voltage. Now if we are supplying this small voltage means uh, this V will be, whatever we are supplying, this V should be varied. I mean here it will be auto transformer, so this supply should be varied till the rated current flows in the secondaries as well. Rated current flows in the secondaries, and for, from the first case itself the primaries are flowing the rated current due to this supply lines. So here it can be, here if you observe here the SC test is performed because I rated is flowing from the windings. In before case, here these are the secondaries. In secondary there is no voltage means no current I said, so there is OC test performing. So if you can observe in Sumpners test we are performing both OC test and SC test simultaneously. So now after giving some voltage by this transformer, as there is some current flowing, that is rated current, there will be a power reading across this wattmeter, and there will be a current in order to measure this I rated. So ammeter in order to measure this I rated. So now here we will get some reading. So this reading W2 reading will be nothing but your copper losses in both the transformers. Similarly, if you want per transformer, PCU will be W2 by 2, and we know that efficiency is nothing but output by output, output by input actually. So I am writing input as output plus, that is wattmeter 1 reading by 2, wattmeter 2 reading by 2 into 100. Wattmeter 1 is nothing but your core loss, wattmeter 2 is nothing but your copper loss, and by 2 is for each transformer. I took denominator as 2 as because it is of each transformer. So this is about the Sumpners test. I will give the PDF link, and if you have any doubts, comment.
Any doubts? Any doubts about Sumpners test?
హలో సార్.
చెప్పండి.
సార్ లాస్ట్ ఆ ఫామ్ లో చూపించరా సార్, W1 W2 కింద?
అది ఎఫిషియన్సీ ఫార్ములా జస్ట్ బై అవుట్పుట్ బై ఇన్పుట్ కదా. ఇన్పుట్ ఈక్వల్ టు అవుట్పుట్ ప్లస్ లాసెస్. లాసెస్ అంటే మనకి ఇక్కడ 2 లాసెస్ ఉన్నాయి, ఐరన్ లాసెస్, కాపర్ లాస్. బై 2 చేసి యాడ్ చేస్తాం.
ఓకే సార్.
కనిపించిందా?
కనిపిస్తుంది.
ఓకే. ఓకే అమ్మా, థ్యాంక్ యూ.